when the population standard deviation is not known and the sample size is less than 30. Okay, so you're going to see that the formula for this is very similar to the formula that we just used when we did know the population standard deviation. Okay, so we have the sample mean minus the t-score. And remember, we talked about the t-distribution is the same as a normal distribution. However, it's been adjusted. It's a family of curves that are represented by a degree of freedom. Okay, so the degree of freedom is represented by the sample size minus 1. Okay. And so in this case, for example, if the sample size was 10, the degree of freedom would be 9, which would tell us which t-distribution to use. Okay, and I'll point that out a little bit more as we work through the problem. So we have 10 randomly selected people who were asked how long they slept at night. The average time was 7.1 hours, and the standard deviation from this sample was 0.78 hours. So we don't know the population standard deviation. We only know the one from the sample. And our sample size is only 10. So we have here that n equals 10. Right? We have our average from our sample to be 7.1. We have our sample standard deviation to be 0.78 hours. Right? And we want the 95% confidence interval. So in this particular case here, we could go ahead and we could put in 7.1 in for the mean minus, we're going to need that t-score. We're going to need to know what that is in a moment. Okay, we have the standard deviation for our sample, and we're going to divide that by the square root of 10. So now, if I pull out here a t-distribution, okay, let's see if that will zoom in at all there. We are looking for the 95% confidence interval. Our sample size was 10, so that means our degree of freedom here is 9. So if I go over here 9 over to 95% confidence interval, I find that my t-score is 2.262, which is telling me that my distribution is shaped such that for the 95% confidence interval, I would be 2.262 standard deviations away from the mean. That's to the left and to the right. Okay, so I have 2.262 substituted into that piece here. Okay. And that's my lower estimate. My upper one then would be 7.1 plus 2.262 standard deviations times 0.78 divided by the square root of 10. Okay. Now, if I was doing a normal distribution, the z-score would be 2. So you can see here I'm multiplying by just a slightly bigger number because my sample size being only 10, it's just not as valid as having a sample size of 30. So I have to widen my range to be confident with a 95% interval. So looking at the graphing calculator here, we will go ahead and type in 7.1 minus 2.262 parentheses for times 0.78 divided by the square root of 10. And giving me an answer of 6.54. Okay, so that's for this lower range here. So I have 6.54 hours. And then with the calculator, I can just hit second enter, arrow back, and change that minus to a plus sign, giving me 7.66 as my upper range. Okay. So I am 95% confident that if I were to take a random sample of people and ask them how long that they slept at night, that the average would fall between 6.54 and 7.66 hours.